Hello students, welcome back again. In this video, we are concentrating on how to find out extreme value of the function of two variables, that is maximum and minimum value of a function. First, we shall discuss what is the working procedure. Working procedure for finding the extreme value of the function. The function f is said to be a maximum at the point x1 y1. Okay, x1 y1. The condition should be what? The partial derivative with respect to x equal to 0 and y is equal to 0. And the second condition is AC minus B square is greater than 0 and A is less than 0. And what is the value of A? A is the partial derivative of f with respect to x twice, or you can also call it as dou square f by dou x square, and B value is dou square f by dou x dou y, and C value is dou square f by dou y square. And the f of x1 y1 is called the maximum value, and maximum value means you need to substitute f of x1 y1 value in the given function, you will get a maximum value. And the condition for minimum minimum at x1 y1 is again the partial derivative with respect to x and y are 0. Here the first condition, that is AC minus B square is greater than 0, and here A is greater than 0 for minimum, and f of x1 y1 is the minimum value. So what is the working procedure? Working procedure is very simple. First you can find the stationary points. The stationary points is obtained by taking fx equal to 0 and fy is equal to 0. Next you can find out the second order partial derivative, that is A, B, C. A means dou square f by dou x square, dou square f by dou y square, dou square f by dou x dou y, and you can calculate AC minus B square. And otherwise you can able to construct a table, and you can write the value of AC minus B square and A, B, C value, and you can conclude the point whether it is a minimum or a maximum. There is other one is called a saddle point. The point which is neither minimum nor maximum is called a saddle point. So for if AC minus B square is greater than 0 and A is less than 0 at x1 y1, then f is called a maximum point and is a maximum value. Similarly, AC minus B square is greater than 0 and A is greater than 0 at x1 y1, then f is called the minimum point. Okay, fine. Now let us discuss one example based on this concept. Just look at the example is very simple. Okay, so let us find the extreme value of the function. Extreme value of the function f of x comma y is equal to x cube plus y cube minus 3x minus 12y plus 20. So let us write the given function as it is. As we know that first we have to find out a partial derivative with respect to x and y. So that is dou square f by dou x is differentiation of x cube with respect to x is 3x square, y cube with respect to x is 0, 3x is 3, 12y is 0 and 20 is 0, because we have used here the principle of partial differentiation, that whenever you differentiate with respect to x, treat y is a constant. With respect to y, x is a constant, y cube is 3y square and 3x is 0, minus 12y is minus 12, 20 is 0. To find the stationary points, as we know already, take fx equal to 0 and fy is equal to 0. 3x square minus 3 equal to 0. 3y square minus 12 is equal to 0. You can take 3 common, you will get x square minus 1 is equal to 0. Again, 3 is never 0. We will take only x square minus 1 equal to 0. Next, this is x square is equal to 1. Okay. You can transform minus 1 to right side. Then x becomes plus or minus 1. Similarly, here you can take 3 common. Okay. You can take 3 common. You will get y square minus 4 equal to 0. So therefore this 3 will never 0, only y square minus 4 equal to 0. Transform minus 4 to right side, you will get y square equal to 4. Then y is equal to plus or minus square root of 4 is 2. Students, you can observe carefully that x takes the value 1 and minus 1 and y is 2 and minus 2. We need to construct a stationary points by using these values. First take x equal to 1, then y value is 2. Then x equal to 1, y value is minus 2. X equal to minus 1, y value is 2. X equal to minus 1, y value is minus 2. Therefore, you will get these stationary points. That is 1, 2, 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2. Next, let us find out. That is fxx, means second derivative of f with respect to x. You have already got fx value. Right? What is fx? 3x square minus 3. You differentiate again 3x square, you will get 6x. You have f of y, that is 3y square minus 12. You differentiate fy with respect to x. Fy with respect to x becomes fxy, that is you differentiate 3y square with respect to x. So here it does not contain any value of x, therefore it will become 0. Now you differentiate fy with respect to y again, you will get 3 or 2, 3 is 6, 6y. Now let us find out AC minus b square and A, B, C value with respect to these points by using the table. Okay. Now we have 1, 2, 1, minus 2, minus 1, 2, minus 1, minus 2 are the points. You write the value of A, B, C and AC minus b square. A value is 6x, x value is 1, you can substitute 6 into 1 is 6 and it is greater than 0. Similarly, b value is 0, write b 0 as it is. What is the value of y? Y is 2, 6 2 is 12, again 12 is greater than 0. We calculate AC minus b square. A value is 6, C value is 12, 6 12s are 72 and it is greater than 0. Similarly, you can calculate by substitution of x equal to 1. Again, it is 6 only. 6 into 1 is 6. Here 6 into minus 1 is minus 6. 6 into minus 1 is minus 6. B is 0 for all. And you can substitute y value. Y is minus 2. This is minus 12. Again, y is 2 plus 12. Y is minus 2. It will become minus 12. You can multiply AC. 6 into minus 12 is minus 72. 6 into 72 is minus 72. Minus 7 into minus 12 is minus plus 72. And you can look at the condition for a minimum point as well as maximum point or maximum value. What is the maximum value? Maximum value means the value of AC minus b square is greater than 0. Okay. AC minus b square is greater than 0 and A value is less than 0. AC minus b square is greater than 0 and A value is less than 0. We call it as a maximum point. For the minimum point, AC minus b square is greater than 0 and A value is also greater than 0. We call it as a minimum point. So other values are not belongs to this category, therefore we call it as a saddle points. Further, we have to find the maximum value. Maximum value is at -1 comma -2. So you can substitute in the function. X value is -1, y value is -2. This is -1 whole cube plus -2 whole cube minus 3 into -1 minus 12 into -2 plus 20. So you will get 30 value. Similarly, minimum value of f of x comma y is at 1 comma 2. Substitute x equal to 1 and y is equal to 2. You will get 2 value. So this is the way to find out maximum and minimum value of a function. Thank you so much for watching. We'll meet in the next video.